So today we are going to the second method of dimensional analysis, Buckingham's pi theorem. So definition of Buckingham's pi theorem is, it states that if there are n variables in a dimensionally homogeneous equation and if these variables contain m fundamental dimension, then they are grouped into n minus m dimensionless independent pi terms. As the statement indicates, if there are n variables, suppose in a question we have given n variables to you. Let us name them as x1, x2, x3, etc. xn. They are involved in a physical phenomenon. Then there will be one variable which will depend upon all other variables. So here I have chosen x1 as the dependent variable and which will depend upon the other variables x2, x3, etc. xn. So these variables are known as independent variables. So I can write these variables as a mathematical equation. x1 is a function of x2, x3, etc. xn, or f of a function of x1, x2, x3, etc. xn equal to 0. The left hand side variable is taken to the right hand side inside to the function. So I can write it as f of x1, x2, x3, etc. xn equal to 0. Now this equation can be considered as a dimensionally homogeneous equation, and here we have now n variables. So as per definition, if there are n variables in a dimensionally homogeneous equation, so we have in our example we have n variables, and if these variables can be represented by m fundamental dimensions. So starting we have studied what are the fundamental dimensions. So the major dimensions what we use over here is MLT. So let us check out what are the dimensions of these variables. So first we have to write down the dimensions of each variables and see how many fundamental dimensions are used over there. So maximum we can use MLT, means we can use maximum 3 fundamental dimensions. Suppose if any one of this dimension is missing in these all variables, it may reduce to 2 or 1. So generally most of the problem we have m equal to 3. Then according to Buckingham pi theorem, we can again rewrite the same equation, this equation, in form of pi terms, f of pi 1, pi 2, etc. pi n minus m equal to 0, where these terms are known as dimensionless pi terms, and each term is equal to, where pi 1 is equal to x2 raised to a1, x3 raised to b1, x4 raised to c1 into x1, x2 equal to x3 equal to etc. Pi 2 equal to, pi 3 equal to, and pi n minus 1 equal to similar case of pi 1. So this is the general structure of a Buckingham pi theorem. We will go in detail what these terms are through a problem.